All right, 2.3. 2.3 kind of talks about a few different things, but it starts off with long division of polynomials. So if you remember this from Algebra 2, we have long division, and there's also a shortcut, which is synthetic division. You have to know how to do both. Hold on. There are some cases where you can only do long division and synthetic division doesn't work. So you have to know how to do both of them. So we're going to start by writing the long one inside the box. So just like how we would do long division with numbers, we do the same thing, but just with terms, with our polynomial here. So 6x cubed minus 19x squared plus 16x minus 4, and then x minus 2 goes outside the box. So there's 3 steps that we kind of follow on repeat when doing long division. First one is dividing. We want to divide 6x cubed by x. So the first term gets divided by the first term. Step 1, divide. So if I have 6x to the third power and I take one of the x's away, what am I left with? Olivia. 6x squared. Awesome. So 6x squared. I'm going to write the x squared term on top of my x squared term. Keep your terms in order. It'll make this easier for you to follow along. Step 2 is to multiply. So we multiply 6x squared by both things out front. So 6x squared times x would be 6x cubed. And what's 6x squared by times negative 2? (6x squared times negative 2). Negative 12x squared. Now step 3 is to change the signs and combine. So we change the sign, and combine them together. So your first terms are always going to cancel out. That 6x cubed minus 6x cubed always cancels. If it doesn't, you did something wrong. Then we have negative 19x squared plus 12x squared, which would be negative 7x squared. Now we do the same steps again. So I'm going to start from the top. We're going to divide. What's negative 7x squared divided by x? Negative 7x. Awesome. So negative 7x. I'm going to write that x term right on top of the 16x. I'm going to keep my like terms in line. Now negative 7x, we're going to multiply times everything out front. So negative 7x times x would be negative 7x times x. Negative 7x squared. And negative 7x times negative 2. Positive 14x. What do I do next? Change the signs and combine. So this becomes a plus and this one becomes a minus. We combine that with the terms above it. So negative 7x squared plus 7x squared cancels. I'm going to drop down this 16x and we're going to combine these two together. 16x minus 14x is 2x. Now we do it all again. We're going to divide. What's 2x divided by x? Two. So plus 2. Then we multiply. 2 is going to get multiplied by both things out front. What's 2 times x? 2x. And 2 times negative 2? Negative 4. What's the next step? Change the signs and combine. So 2x minus 2x cancels. Then I have negative 4 plus 4, which would be 0. So once we run out of terms, once we hit our constant and we have nothing left, everything after that would be our remainder. So here our remainder is just 0. So when we divided, our answer is 6x squared minus 7x plus 2. Now, the question says, use the result to factor the polynomial completely. So let's factor this. How would I factor when my leading coefficient is not 1? Multiply the first times the last. So 6 times 2 would be 12. What are two factors of 12 that add to negative 7? Does negative 6 and negative 1 multiply to 12? Negative 4 and negative 3. So we have x minus 4 and x minus 3. What do we have to remember to do if we start with multiplying? We have to divide it by 6. So divide by 6, divide by 6. Simplify your fraction if you can. Can I simplify 4 over 6? What does it simplify to? 2 over 3. Whatever's left in your denominator that doesn't simplify gets moved in front of the x. So this would be 3x minus 2. Can I simplify 3 over 6? What does it simplify to? 1/2. Whatever's left in the denominator gets moved in front of the x. So this would be 2x minus 1. So these would be our remaining factors. So here we have our x cubes lined up, all the x squareds lined up, the x's lined up, and then the constants line up. You want to keep your terms in line. That'll help you know what's going to come next. If I already have an x squared term when I divide, I'm not going to put another x squared term. So keep your terms in line to help you know what's coming next. Olivia. If this was a WebAssign question and it wants the complete factorization or to write out the complete factors, we factored it completely, so we got 3x minus 2 and 2x minus 1. What else do you think is a factor of this? We started with 6x to the third power, so we need 3 x's there. I only have 2 of them. Not 0. So the other factor, which we'll talk about this a little bit more tomorrow in part 2, would be what we divided into it. So that would be x minus 2. So if you divide into it with a binomial and you get 0 as the remainder, 0 as the remainder means that it's a factor. So that's how we got x minus 2 as a factor, which this is, I think that they call it also the remainder theorem or something else along those lines, but we'll talk about it more in part 2 tomorrow. There's more slides, more examples, yes. But just to kind of give you guys a head start on the homework, if it asks for the complete factors, you're going to write it out like in factored form. A lot of the questions just ask to divide, which would just be kind of like what we did on the second page. So looking at number 2. The long one, what we're dividing into it, goes inside the box, but we have to make sure all of our terms are accounted for. If I start with x to the second power, I need an x and a constant. I need every term after that. So I'm going to start with x to the second power. What do you think I'm going to put in place of the x part? 0x. Awesome. 0x is just going to act as our placeholder. So 0x minus 74. And we're dividing that by x minus 8. Now you don't have to put the 0x, but if you don't put it, make sure you leave a space, because we want all of our terms to be in line. So we need, whether it's a space there or put a 0 there, I think it's easiest just put a 0x. That way you can keep with the same steps. So what's step 1? Divide. What's x squared divided by x? X. So I'm going to write that on top of my x term. What's step 2? Multiply. So x times x and negative 8. X times x would be x squared. X times negative 8. Negative 8x. What's step 3? Change the signs and combine. So this becomes a negative, this one becomes a positive, and we're combining them. So the x squareds cancel. 0x plus 8x would be 8x. Then we repeat from the top again. We divide. What's 8x divided by x? 8. So plus 8. Then we multiply. What's 8 times x? 8x. What's 8 times negative 8? Negative 64. What do we do next? You can bring down the negative 74, but we can't forget to do what? Change the signs and combine. So the 8x's cancel. Negative 74 plus 64 would be negative 10. Can I divide negative 10 by x? Can I take away any x's here? No. So this is going to be our remainder. So our answer would be x plus 8, remainder, negative 10. Now this would be fine on a test or quiz, but WebAssign's not going to accept this as an answer. They want you to write your remainder, or you write your answer as x plus 8. Then it would be minus 10 over whatever we divided into it. So x minus 8. And it's minus 10 because it was a negative 10. So minus 10 over x plus 8. This is how WebAssign's going to want your answer. Leaving it as a remainder like r negative 10 would be perfectly fine on a test or quiz. But it's also important to know that writing it as a fraction is the same thing because it would probably be written like this on an SAT. SAT could have it written either way. I've seen them both ways, but knowing that they're the same is important. Any questions here? All right, so we're going to write the long one in the box. We've got 2x squared minus 17x minus 38. Am I missing anything? No, we're good. Outside, we're going to put 2x plus 3. What's step 1? Divide. So 2x squared divided by 2x would be what? X. Awesome. What's step 2? Multiply. So we have x times 2x would be 2x squared. What's x times 3? 3x. Good job, guys. What's next? Change the signs and combine. So step 3, change the signs and combine. Don't forget this step. Change the sign, combine. 2x squared minus 2x squared cancels. Negative 17x minus 3x would be negative 20x. Now we start from the top. We divide again. What's negative 20x divided by 2x? Negative 10. Awesome. Negative 10 times 2x would be negative 20x. And negative 10 times 3? Negative 30. What do we do next? Change the signs and combine. Negative 20x plus 20x cancels. We have negative 38 plus 30 would be negative 8. So negative 8, can we divide any more? Nope, that is our remainder. So we'd write our answer as x minus 10 minus 8 over 2x plus 3. Yeah, if the remainder is positive, you'd put plus. You just keep the sign of whatever the number is that's your remainder. So notice how in these questions, the like terms are always lined up. So we have x squared, then we have the x's, then we have our constants. So if our remainder, let's say we had x minus 10, remainder 5, we'd write this as x minus 10 plus 5 over 2x plus 3, like this. So it just kind of keeps the same sign as whatever your remainder is. But if it was a negative, you're going to put minus. If it's positive, you put plus. Next page just talks about like the vocab behind it. You've got the dividend, divisor, quotient, remainder. Next page, we get into like the shortcut of it. So this is synthetic division. So you can do long division or synthetic division. It's this two different ways of doing the same thing, finding the same answer, but sometimes synthetic division doesn't work. So if the instructions say use long division, make sure you practice doing long division too. So when we do synthetic division, we're going to start by, it'll give us a term, a polynomial that we're going to divide into, and then the thing that we're dividing by. Notice here how it's x minus k and positive k goes on the outside. You always change the sign of what goes on the outside. So if I was dividing by x plus 5 and I'm doing synthetic division, what would go on the outside of my box? Negative 5. So we always change the sign. So in example 4, we've got 3 examples here. So I'm going to start by drawing my box. Outside of the box, what would we put here? Negative 3. Awesome. We always change the sign. Inside of the box, we just put our coefficients, and we have to make sure every term is accounted for. So here I start with x to the 4th power. Do I have x to the 3rd power? No, so what am I going to need to put in that place? 0. So I'd put a 0 x to the 3rd power. Then I have x to the 2nd power, x to the 1st power, and our constant. So we're good there. So now I'm going to put my coefficients in the box. What's the coefficient of x to the 4th power? What's the number in front of it? 1. So we'd have 1, 0, negative 10, negative 2, and 4. So coefficients, numbers in front, go in the box. Now for synthetic division, you always drop down the first number, and you're going to multiply the numbers outside. Multiply outside. So negative 3 times 1 is negative 3. Then you're going to add on the inside. So 0 plus negative 3. Negative 3. Outside, again, we multiply. Negative 3 times negative 3 would be 9. Negative 10 plus 9. Negative 1. Negative 3 times negative 1. 3. Negative 2 plus 3. 1. Negative 3 times 1. Negative 3. And 4 plus negative 3. 1. All right, so now the answer that we just got is going to be the coefficients of our answer. We always start with 1 less than our highest degree term. So if I start with x to the 4th power, my answer is going to be 1 less than that. So x to the 3rd power. Then we have minus 3x to the 2nd, and we just go down from there. We descend from there. Minus 1x plus 1 is our constant. The last number is going to be our remainder. So here we have x cubed minus 3x squared minus x plus 1, remainder 1. Or if this was a web assigned question, we'd say x cubed minus 3x squared minus x plus 1 plus 1 over x plus 3. All right, let's look at example 2. Any other questions with that one? Again, for synthetic division and with long division, it's the same steps, the same pattern. The first time you may not see it, it may not come super easy to you, but the more you keep doing it, the more you practice, you're like, oh, this is a breeze. It's the same thing every time. So let's do number 2. So what's going to go outside the box? Positive 8. We always change the sign, so positive 8. Inside the box, we got to make sure all of our terms are accounted for. So we have x squared, x to the first power, and our constant. So we're good there. What numbers are going to go in the box? 1, -7, -11. Perfect. What do we do next? Perfect. Drop down the 1. Then outside, we multiply. 8 times 1 is 8. Inside, we add -7 plus 8, 1. Outside, we multiply. 8 times 1, 8. Inside, we add -11 plus 8. -3, thank you. Once we're done, this is our answer. We just have to put the x's with it. So if I start with x to the second power, what's my answer going to start with? X. It'll be 1 less than what the question starts with. So x plus the constant, the last number is your remainder. So here we have x plus 1. For web assign, when we have to write it as a fraction, we'd say -3 over x minus 8. You can leave it like this if you want to on a test or quiz, if you like writing it like this, but writing it with the r is fine too. So you could say x plus 1, r -3. This works also. Web assign's just going to want it as a fraction. Any questions? All right, number 3. What goes outside the box? -5. What goes inside the box? 1, 10, and 18. What do we do first? Drop down the 1. What do we do outside? Multiply. -5 times 1. -5. -5 plus 10. Positive 5. 5 times -5. -25 plus 18. -7. Awesome. Now these are our coefficients for our answer. We got to put the variable part in. If I start with y to the second power, what's my answer going to start with? Y. Then plus 5. Last number is our remainder. So y plus 5, remainder -7. Or for web assign, we got to write y plus 5 minus 7 over y plus 5. So the remainder theorem helps us evaluate the polynomial at a certain number. So you'll see on the next page, it'll say evaluate at like x is equal to 5. We're going to do synthetic division. Whatever the remainder is going to be what we would get if we evaluate at that number. So when it says use the remainder theorem to evaluate, you're doing synthetic division, and the remainder is going to be your answer. So the remainder is our answer. So in example 5, it says use the remainder theorem to evaluate. Here we have to be a little bit careful because it's a little bit different than what we were doing when we were dividing before. When it says x is equal to a number, that exact number is going to go on the outside. So -2 goes on the outside. don't change the sign. You would only change the sign. The last ones had like x plus 2. This is when you would change the sign. If it says x equals, you put it exactly how it says. Inside the box, are we missing any terms? We have x to the third power, x to the second, x to the first power, constant. Not missing anything? We're good. Let's put it in the box. So we have 3, 8, 5, -7. What would we do first for synthetic division? Drop down the 3. What do we do outside? Multiply. So we get -6. Add. We get 2. Multiply. -4. Add. 1. Multiply. -2. Add. -9. Now this says use the remainder theorem to evaluate. When it says use the remainder theorem, just the remainder is our answer. So our answer would just be -9. If I were to take -2 and plug it into all of my x's and worked it out, if I plugged in -2 into x cubed, so -2 cubed times 3 plus 8 times -2 squared plus 5 times -2 minus 7, did all that math, you'll get -9. So this is like a shortcut for evaluating. Kind of depending on how long your polynomial is, it might be easier, like if you had something like this, to just plug it in. But when you have something really long like this, synthetic division is super helpful to just do synthetic division. Whatever the remainder is what you'd get if you plugged in this number. Does that make sense? No, because x was -2, so it's technically f of -2 would be -9. So -9 would be like what you get when you solve. Your x was -2. Questions here? All right, let's do the next one. So for 2, we're going to do long synthetic division again. What's going to go outside the box? 1. Awesome. When it says k equals or x equals, you put exactly what it says outside. What's going to go inside the box? 1, -7, 10. We're going to drop down the 1. What do we do outside? Multiply. So we get 1. What do we do inside? Add. We get -6. Multiply would be -6. Add. We get 4. What's our answer? 4. Awesome. You could, technically this would be written as k of 1 is equal to 4. Our answer is 4. So whatever the remainder is your answer. If you're evaluating when your variable is a certain number, your answer is just the number. If it said divide, you'd want the k minus 6 remainder 4. But here we're just evaluating. Let's do number 3. What's going to go outside the box? 5. When it says a equals, you put exactly what it says. What's going to go inside the box here? Awesome. 1, 0, -28. We're missing the a term, so we'd put a 0a. So 0 goes in that a spot. We're going to drop down the 1, multiply, we get 5. Add, this would be 5. Multiply, 25. What's -28 plus 25? -3. What would our answer be? -3. So if we said f of 5 would be -3. -3 is our answer. So the homework's part 1 and part 2. We just did part 1 today, but we'll do part 2 tomorrow. If you can kind of look at it, and it's a lot of the same stuff, just synthetic division. Some homework questions want you to write the answer a little bit differently. If it says divide, you're going to write it with the polynomial as the answer like we would. If it says to write out the factors or factor, I think the first one says factor completely, you'd write your answer in the parentheses, like in factored form. Or it could say write the complete factorization This also wants the answer in factored form, so write out all of the factors of it.